On the meetup page, they say I will be telling you a story, an exciting story, right? So, once upon a time, there was this board with an 80 mega 8 microcontroller, and suddenly it got an IP address. So this is a happy end. Really, it was exciting to see that tiny microcontroller be able to do all the TCP/IP protocols. And for me, at least, this was exciting back then when the IoT was not yet a buzzword. But I didn't do only digital electronics. I had my weird hobbies with high voltage. The two didn't mix well together. So I tried to do a few things, and there were all these high voltage spikes, which burned quite a few of my semiconductors. But nevertheless, there were some lessons to be learned. To get this nice performance, it's really not easy to spark that long. You would need quite a few capacitors and some other components and a careful design. Actually, I didn't do this thing. I just reconditioned it from an old Spellman or something, or Glassman. There was some high voltage power supplies available back then. Quite robust, and I used them a lot for some of my high voltage experiments. Those involved lifters, some particle accelerators, X-rays, and things like those. So yeah, it was quite interesting to have the time to play with such things. And from a point, learning to build high voltage inverters was useful, because I learned to build really small transformers to do my own coils, and I learned all those things from building the high voltage things. So there were precious lessons in everything I did there while playing, like it happens every time. So what's with this equation? I have the Ethernet and the GigaTube, because the high voltage inverters, I built them as drivers for GigaTubes. You know that you need a few hundred volts to be able to use a GigaTube. So that is why I needed those inverters. So for me, this was the first IoT device I built. It was actually a combination between a device with an Ethernet module and a GigaTube. I know it's a bit weird, but it was featured on Hackaday, and that was wow, really, because I got a lot of feedback. Just yeah, and there were guys which knew a few things that I was able to put into practice, and from the thing you see in the picture, which looked quite good for a prototype, I dare to say, there are a few floating wires here and there, and there's some water that can easily go into the enclosure, but still, it functioned okay. I was able to minimize everything and build something which could be replicated and which is somewhat closer to a product, if I can call it that way. But still, just see that board etched in the kitchen with ferric chloride, and check out the nice cuts all around the components, which were done by hand. I'm still using the Ethernet module. So I was too lazy to make everything on one PCB. Actually, I was able to have something close to a four-layer board. So you are seeing a 4-layer board there. It saved me precious space, and yeah, that was a very economic solution to what I needed. And yeah, also the enclosure was manually drilled and cut, and I was able to scale everything. So from 1, I got to 10. So the key here was to have a design which was easy to be replicated, like having just the right components, not one capacitor extra, to have them placed in a convenient way. So it's not very hard to place them and mount them and so on. And this was important back then, because if anything wrong would have happened at that step, probably it would have been too much of an obstacle for me. So I got the right recipe from the first step, and that was good. And then with the Hackaday prize, I went as far as the semifinals, and that was awesome. Like I never hoped for a hobby project to get this much importance, and then because of the Hackaday prize, this guy came along, and so when Dave Jones came in his mailbag videos with my unit being featured, he took the power supply I shipped to him. He was like, "Ah, what's this crap?" He just threw it away. He was right. It was a very cheap Chinese power supply, which I've been using just because it was small. So for me, it was it was very easy to pack it and ship it. So that was the single reason for using that power supply. But everything else was good. So I'd say I was lucky. So because of Dave and the Hackaday prize, the interest just went up, and I was able to reach 100 units right away. So think about what we are talking about. This is an Ethernet-connected Geiger counter. Who needs such a thing? Still, as for me, it was very interesting to see the numbers, radiation, monitoring, seeing the numbers 24/7. I was curious about what's in that data, and I think the guys, the early adopters, felt the same. I have no other explanation about this. It was a very niche market segment, and somehow things worked there. Then I had to go the commercial way, and I founded my startup by the end of 2015. And right after, I had the honor to be in this place right before the Hackaday prize. It was awesome. The event was much bigger than the last year. It was the super conference coupled with the Hackaday prize. It was awesome, really. It remained in my mind like one of the best moments of my life, and I'm so happy that I've been part of that. And I just pushed on. And it was somewhat easy because I got everything in place already. So it was just a matter of seeing what exactly people need. And the Geiger counter thing was not the right answer. I still have that unit because it still finds its use in some certain scenarios. And I tried to do more than that. And it was easy because the only thing I had to do was to add more sensors. So really, it's nothing more than that. It's an infrastructure which is built on an IoT topology. You have a connectivity, and you have a bunch of sensors. And of course, there's also some software for the data storage and a server and so on. But still, it's the same structure. And building on that was just a matter of identifying some sensors that can answer to some questions, like you are concerned about pollution. Okay, what are the emissions in a city? What are the worst things that can impact our health, and so on. So it's about talking with the right people and learning more about what you're trying to achieve with such a solution. And this started to be very time-consuming from a certain point, and I realized that, okay, it's fun to do the soldering. I still love to do that. It's one of the most relaxing things to have a beer, watch a film while doing some soldering, and from a point I didn't have enough time for that, and the biggest problem was debugging. Like, you have this device, it looks perfectly fine, very clean solders, and it's all good, but for some reason it doesn't work. Okay, so find the problem. Where's the problem on the board? It can be a bad solder, it can be anything, and it's so hard to spot it. At a point, I started to use a thermal camera for debugging purposes. Just yeah, I had a FLIR camera just to see if some components were getting some extra heat, and that helped in some situations. But this was a very time-consuming process, and since I started doing the boards by hand, for me, these things were very precious. Like, it was so hard to get the right traces with board etched by hand, and now when I had these professionally made boards, having one that doesn't work, it was a challenge and I couldn't let it go. So I started to waste a lot of time on doing these things by hand. So the solution was to go east and do some outsourcing there. And this was easy because when you order an assembled board, you not only pay for the components and assembly work. The funny part is that you also pay for a working assembled board. So that includes the debugging, if any. And this is very convenient. So yeah, I had to move to China. And here are some boards being made there. Yeah, there are some problems, like in some situations, these guys are not careful enough to take good care of your small ferrite cores, which are at the bottom of these boards. And when you get them, you'll see that half of them are broken. And they still work. They still have enough inductance, and they perform quite well. But of course, that I had to replace those things to have a perfectly looking board. Then the testing. Okay, the testing could be tricky, but for an IoT device, this is so easy. Like, I have this script on the server which just takes the data, and the devices only have to be connected for a number of minutes, and the script will just check all the parameters automatically. So the guys doing the testing in the Chinese factory will get a red or a green label, and if it's red, they will need to start all over again. And when everything is green, then okay, we can ship, and the device is good to go. So this is again doable and extremely easy for an IoT thing. Assembly, screws, putting the aluminum enclosure. Also, the aluminum enclosures are now being made there because they have so many tools. Like for a device, I don't think I have it in these pictures. I wanted to have a fancy shape on the metal enclosure. So about 4 factories said, no, it's too complicated, but I found one which did it, and I got my fancy design. It was totally useless, but it provided a nice grip when holding it in your hand. So yeah, I loved it. And finally, the project just reached 1,000 units worldwide. And thank you, guys. And I'm so happy to be here to say thank you to those that really helped to get here. And talking about Tindy contributed to this as well. So yeah, it's a great thing to have them on Tindy. And I just need to find more time to put more hardware there. And I also hope to have the time to get back to the things I love most and design other small gadgets and have the time to play more. But all in one, this was the story. So in case I can help with any answers on some particular things related to the prototyping I did, or about the shipping, or things like those, feel free to reach out. I'd be happy to answer any questions. Thank you very much.